Assalamu alaikum wa rahmatullah. Look, today we are going to look at another example relating to Kc value. We got a question: 1 mole of pure ammonia is placed in a 2dm cube container, and the following equilibrium is established. 2NH3 gives you N2 plus H2. Okay, what you should know here, I didn't write it down. All of them are gases, right? All of them are gases. So they're gases. So just remember that they're all gases. I just write it down for us. And that equation is balanced. All right. Now the question is, when equilibrium is reached, it is found that the container contains 0.6 moles of H2 of hydrogen. Calculate the equilibrium constant for the system. Okay, now if you see a sum like this, they gave you the volume of the container, which is 2dm cubed, right? And they're telling you at equilibrium that 0.6 moles of ammonia is available at equilibrium. All right. I think, and I tell you also that 1 mole of NH3 is placed in the container, 1 mole of NH3. So let's just highlight those points. Let's see what we've got, right? We've got 1 mole of NH3. We've got a 2dm cube container, and we've got 0.6 mole of H2. So all the other information is not given. But what we could do is we could work out the Kc value using a table method. All right. So let's just clear everything, clear all drawings. Right. So now draw this table for me. All right. Let's just go next equation. Here's the same story. I just made it small so we can have it in our mind's eye when we are doing the sum. All right, so I want you to draw a table where we got the number of moles at the start of the reaction. We've got 1 mole of ammonia, right? Number of moles used or formed, which we don't know, and number of moles at equilibrium will be 0.6 moles of hydrogen. And the concentration of ammonia, anything else, nothing else is given. Put that in your table. So draw a table like this. Put one block empty on the top. Draw your table with your reactants, NH3, N2, and H2. We know that this is, I put a double line here to show that the NH3 is your reactant, and the right hand side of the double line is your product. You put another, you could put it as another column here, or another shade, or make or put a double arrow there, whatever the case is, just to demarcate it, right? Put a double line. Number of moles used will be the NH3. The NH3 will be used because you started off with NH3. Number of moles formed will be N2 and H2. Number of moles at equilibrium will be 0.6 moles of H2 at equilibrium. Right, now we can start doing the sum. How do we do the sum? When we put all the values in, I'll have to write here, so I think I'll have to just, right, if we have to write here, we have to see what we've got, right? So we've wrote down 1 mole of NH3 is given, and 0.6 moles of H2 is formed. So if you look at the rationale, at the beginning, we had 0 moles of H2. We had no H2 at the beginning. And at the end, we got 0.6 moles of H2 at equilibrium. So what can we say? If there was nothing at the beginning and 0.6 moles is found at equilibrium, then we can use logic and we can say 0.6 moles of H2 were not used, were formed. Correct. So we can say 0.6 moles of H2 are formed. So you got your first line, you got something in the third line, and from there now, we can work out our second line. Now to continue, before we continue, I told you to leave a line here on the top. because I want you to write down your mole ratios. Right, what's the mole ratio of NH3? If you look at it, what's the balancing number? 2. Oops, I'll have to change the color there. What's the balancing number of nitrogen? 1. What's the balancing number of hydrogen? 3. All right, let me just change the color so we can see it nicely. Let's just make another decent color. I don't know what's a decent color. Let's just whatever comes. All right, so those are the balancing numbers from there. So now that we know the balancing numbers, how many moles react, we've got 0.6 moles of hydrogen that were formed. If that were used, so if 0.6 moles of hydrogen are formed, using our mole ratio, can we work out this second line? Number of moles of ammonia that were used and number of moles of nitrogen that were formed. So if you look at our mole ratio, 2 NH3 will form 1 N2 and 1 and 3 H2. So it's 2:1:3. So if hydrogen is 0.6, what will nitrogen be? You divide 0.6 by 3, isn't it? And you get 0.2 moles of nitrogen that were used. And how many moles of ammonia reacted? It will be 0.6 divided by 3 times 2. So it will be double that amount, right? So it will be 0.4. So 2:1:3 will give you the same ratio as 0.4 to 0.2 is to 0.6. So if 1 is 0.2, 2 will be 0.4 and 3 will be 0.6, right? So we know that the amount of ammonia used must be getting less, it's used, right? And formed will be getting more. So it will be increasing. 0.2 will be increasing and 0.6 will be increasing. So if you add, now that we've got the second line, we know that 1 mole of ammonia was in the container at the beginning, 0.4 was used. So we can use that to work out how many moles will be left at equilibrium. So 1 is what you have, 0.4 was used. So what will be left? 1 minus 0.4, 0.6 moles at equilibrium. All right. And then you had no nitrogen at the beginning. 0.2 was formed. So how many moles will be there at the end at equilibrium? 0.2. And the hydrogen we worked out before that, right? Nothing was there. We had 0.6 at the end, so that means 0.6 was formed. Now we know that the number of moles that are found at equilibrium in this closed reaction vessel, right? Must be closed because we've got a double arrow, it's a closed system that we're talking about. Then we can use this moles now, we can use these moles to work out the equilibrium. So how do we work out the equilibrium? How many, what's the size of the container? If you look at our question, we see it's a 2 mole container. So we know the equation C is equals to N over V. So use C is equal to N over V and work out the equation for me. You can work it out while I'm trying to do it using all these things, equation. So work out the concentration of all the substances at equilibrium. Number of moles N over V. And then it will be 0.6 divided by your volume will be 2 in our case, right? So it will be 0.6 divided by 2. Let me just write down 0.6. Oops. Divided by 2 will give you 0.3. So write those values down while you are waiting for me. So we say 0.6 divided by 2, which will be 0.3. Right. And if you have to work out nitrogen again, it will be same story. 0.2 divided by 2, which will give us 0,2 divided by 2, which will give us 0,1. And if we have to work out the next one, it will be again the same story, 0,6 divided by 2, the volume, and that's going to give us 0,3. Okay, so those are the values that we know. Now we could work out the values at concentration. So we've got the concentration of ammonia, we've got the concentration of nitrogen, and we've got the concentration of hydrogen. Now, could we work out the Kc value? Can we work out the equilibrium constant? What do you know? All right, we know that we can, we've got this down. We can write down the equilibrium constant. Write down our Kc. Kc is equals to products over reactants, right? N2 to the power 1 multiplied by H2 to the power 3 divided by NH3 to the power 2. All right, NH3, there's a mistake there. The 3 is supposed to be a subscript. All right, I'll fix it up just now. If we write that down, we have our values now from the table. We can write down 0,1 is the nitrogen and 0,3 is our hydrogen, and you must cube it, 0,3 cubed. All right, and our ammonia is 0,3, that must be squared. All right, because that's the balancing number. And then if you take our calculator and you work it out, what answer do we get? The answer that we get will be our Kc value for the reaction is 0,03. Okay, so that will be how you will do a basic sum using the table method. Okay, so there's it. All right, you put it there, you put it there, you put it there. So that will be a basic table method sum in doing an equation on Kc. So let's just go back a little bit. All right, we had this equation. 1 mole of ammonia is placed in a 2 dm cube container and the following equilibrium is established. NH3 gives you N2 plus H2. It must be balanced. They must all be gases. We're telling you 0,6 moles of H2 is found at equilibrium. Calculate the equilibrium constant. So then we put down our table. And if you look at the table, we started off with 1 mole of ammonia. That's given here. And they're telling you 0,6 moles of hydrogen is given there. That's why I put it in a different color. I put a double line here to show you the reactants are used and the products are formed. And then we said, okay, 1 mole of ammonia is what we had at the beginning. So there's 0 moles of nitrogen at the beginning and 0 moles of hydrogen at the beginning. And at the end, we know that there's 0,6 moles of hydrogen. Those are the only things that we know. So we got first line and we got something in the third line. Then we said if there's 0 hydrogen at the beginning and there's 0,6 moles of hydrogen at the end, how much of hydrogen was formed? We saw that 0,6 moles of hydrogen will be formed. Then we took the mole ratio. The mole ratio is from the balancing numbers here, right? 2:1:3. So 2 moles of ammonia reacts with 1 mole of nitrogen to form 3 moles of hydrogen. So if there's 0,6 moles of hydrogen, and that's 3 parts, then one part of 0,6 will be 0,2. So 0,2 nitrogen is formed, and 0,4 is 2 parts of 0,2. 0,6 is 3 parts. This will be 1 part, 0,2, and 0,4 will be 2 parts, right? 2:1:3, 0,4 is to 0,2 is to 0,6. So 0,4 moles of ammonia is used. So then we've worked out the second line. Then if we got 1 mole of ammonia, 0.4 moles is used. So 0.6 moles will be left at equilibrium. We had no moles of nitrogen at the beginning. 0.2 moles was formed. So we know that 0.2 moles of nitrogen will be found at equilibrium. And the 0.6 they told us was there at equilibrium. Right, then we know the number of moles at equilibrium. We can work out the concentration at equilibrium. We use the equation C is equals to N over V. The number of moles, we just worked it out in the line before. Now, in the volume, we know that the volume is a 2 dm cube container. So we take 0.6 divided by your volume, which is 2, which gives you 0.3. We've got 0.2 nitrogen divided by 2, which gives you 0.1. We've got 0.6 of hydrogen divided by 2, which gives you 0.3. So now we've got the concentration of ammonia, nitrogen, and hydrogen at equilibrium. Now that we've got the concentrations, we can put it in our Kc value. We've got the Kc is equals to nitrogen, hydrogen to the power 3 cubed divided by ammonia squared. And then we put those values that we got from the table, 0.1 times 0.3 cubed, all over 0.3 squared. And if you work it out, we see that our Kc value is 0.03. And just before I conclude, if the Kc value is 0.03, what can we conclude? Is the equilibrium shift to the product side or to the reactant side? We know that if the equilibrium is less than 1, the equilibrium lies more to the reactant side. So there's more NH3 in the reaction vessel than the N2 or the H2. Okay, so we will stop at that point and we will take some questions.